Hello dear students, glad to meet you in this session 1.8. In this session 1.8, we are going to discuss about the gram equivalent mass in chapter 1, some basic concepts of chemistry in grade 11. Before getting into today's concept, let us recall all the topics that we have discussed in the previous sessions. In session 1.1, we have discussed the importance of chemistry and nature of matter and its classification. In session 1.2, we have discussed the 7 basic units of SI system, its definition and its symbol. In session 1.3, we have discussed the physical quantitative properties of matter, and under this heading, we have discussed about mass, weight, volume, density, and temperature. In session 1.4, we have discussed the uncertainty in measurements, and under this heading, we have discussed about scientific notation, significant figures, precision and accuracy, and dimensional analysis. In session 1.5, we have discussed about the laws of chemical combination. In session 1.6, we have discussed the postulates of Dalton atomic theory, atomic mass, molecular mass, and formula mass. In session 1.7, we have discussed the mole concept, Avogadro number, molar mass, and molar volume. Learning outcomes. Students, at the end of this session, you will be able to define gram equivalent mass, understand the concept of gram equivalent mass for oxidizing and reducing agent, acid, and base. Students, in the previous session, we have discussed about mole concept, which is based on molecular mass. So we know that 1 mole equal to 6.0221367 into 10 to the power of 23 atoms or molecules. And this number is nothing but the Avogadro number. If we take carbon as an example, 1 mole of carbon contains 6.0221367 into 10 to the power of 23 carbon atoms. If we take only one carbon atom, the mass of one carbon 12 atom is 1.6605 into 10 to the power of minus 27 kilogram. So during chemical reaction, we won't consider atomic mass unit. So in chemical reaction, we use the term mole in grams. Now in this session, we are going to discuss about gram equivalent mass. You know that mass is the amount of matter present in a substance. The equivalent concept is based on equivalent mass. Before getting into the concept equivalent mass, let us see what is the difference between equal and equivalent. Now let us see what is equal and what is equivalent. Look at this picture 1. We have 2 plates A and E, consist of same number of same fruits. Since we have same number of same things, we can say plate A is equal to plate E. Now look at this picture. Plate A contains a set of fruits and plate B contains set of balls. There are 5 things on both these plates. The number of things are equal. The double-headed arrow shows us there is 1-to-1 correspondence between these 2 things. Though we have same number of things in both the places, the objects are different. They are not identical. So we can say that plate A is equivalent to plate B. If we have same number of same objects, then it is equal. If we have same number of different objects, then it is equivalent. Hope now you could have understand the word equivalent. Now let us see what is gram equivalent mass. First, let us see the definition. The mass of an element, that element may be a compound or ion, that combines or displaces 1.008 gram of hydrogen or 8 grams of oxygen or 35.5 grams of chlorine is called gram equivalent mass. Let us see this definition with an example. Here, let us take the reaction between zinc and sulfuric acid. In this reaction, 1 mole of zinc, that is 65.38 grams, displaces 1 mole of hydrogen molecule, not atom. So the weight of hydrogen molecule here is 2.016 gram from sulfuric acid. But the definition of gram equivalent mass tells us the element displaces 1.008 grams of hydrogen. So we need to find the mass of zinc required to displace 1.008 grams of hydrogen. For that calculation, we have to divide 65.38 upon 2.016 into 1.008, which gives the answer 32.69, and this is the gram equivalent mass of zinc. So the gram equivalent mass of zinc is 32.69 gram per equivalent. Definition of gram equivalent mass is not suitable for the reactions which do not involve hydrogen, oxygen, or chlorine. For example, in the case of redox reaction, they involve electron transfer. So for these kind of reactions, the most useful expression is gram equivalent mass is equal to molar mass upon equivalent factor. On the basis of this expression, let us find out the formula for calculating the equivalent mass for redox reactions and also for acids and bases. Equivalent mass of oxidizing and reducing agent. The chemical entity that we have taken here is an oxidizing or reducing agent. We know that the redox reaction involves the transfer of electrons. So first let us calculate the N factor, that is the equivalent factor. It is nothing but the number of moles of electrons gained or lost by 1 mole of the reagent during the redox reaction. Now let us find out the formula for calculating the gram equivalent mass of an oxidizing and reducing agent. From the general formula, we know that gram equivalent mass is equal to molar mass divided by equivalent factor. So to find out the gram equivalent mass of oxidizing or reducing agent, it is equal to the molar mass of the oxidizing or reducing agent divided by, what is the N factor here? Number of moles of electrons gained or lost by 1 mole of the oxidizing or reducing agent. This is the formula to calculate the gram equivalent mass of oxidizing and reducing agent. Now let us see this concept with an example. Let us see how to calculate the equivalent mass of KMnO4. KMnO4 is an oxidizing agent. To calculate the equivalent mass of KMnO4, first we need to find out the molar mass of KMnO4. How to find the molar mass? If we add the atomic mass of all the constituent present in the compound, we can find the molar mass. So molar mass of KMnO4 is equal to the atomic mass of potassium is 39. Here we have 1 potassium, so 1 into 39 plus the atomic mass of manganese is 55. Here we have 1 manganese, so 1 into 55 plus the atomic mass of oxygen is 16. How many oxygen is there? 4. So 4 into 16. When we sum up all this atomic mass of the element present in KMnO4, we get the molar mass of KMnO4. In acid medium, permanganate is reduced during oxidation and the equation is given below. Here in this reaction, permanganate is reduced, which means it gains electron in this reaction. Let us consider the permanganate ion in this reaction. The valency of oxygen in permanganate ion is 2. So here we have 4 oxygen atoms. So 4 into 2 is equal to 8. The charge of oxygen in permanganate is 8. Since the charge of MnO4 minus ion is minus 1, the oxidation number of manganese in MnO4 minus ion is 8 minus 1, which gives plus 7. So the oxidation number of Mn in MnO4 minus ion in the left hand side is plus 7. Coming to the right hand side, the charge of manganese ion is plus 2. It is very clear that on the left hand side of the reaction, there is an excess plus 5 charge on manganese ion. So to neutralize that excess plus 5 charge, it needs to gain 5 electrons. So from this reaction, we know that the equivalent factor N for this reaction is 5. To calculate the gram equivalent mass of KMnO4, we need to divide the molar mass of KMnO4 by its N factor. So 158 divided by 5 gives 31.6, which is the gram equivalent mass of KMnO4. Equivalent mass of acids. The chemical entity we use here is acid. For acid, the equivalent factor N is the basicity of the acid. Basicity of the acid is the number of moles of ionisable H plus ions present in 1 mole of the acid. We know that the gram equivalent mass equal to molar mass by the equivalent factor. So now let us find out the equivalent mass of acid. The equivalent mass of acid is equal to molar mass of the acid by basicity of the acid. which is the N factor of an acid. Now let us see this concept with an example. Let us take sulfuric acid as an example and calculate the equivalent mass of sulfuric acid. When you look at the formula of sulfuric acid, it has 2 H plus ion and 2 SO4 minus ion. So the ionizable H plus ion in 1 mole of sulfuric acid is plus 2. So the basicity of sulfuric acid is 2 equivalent per mole. The equivalent factor N of sulfuric acid is equal to 2. Now, to find out the gram equivalent mass of sulfuric acid, first we need to find out the molar mass of sulfuric acid. To find the molar mass of sulfuric acid, we need to add the atomic mass of all the elements present in sulfuric acid. The atomic mass of hydrogen is 1. Since we have 2 hydrogen, 2 into 1 plus the atomic mass of sulfur is 32. We have 1 sulfur, so 1 into 32 plus the atomic mass of oxygen is 16. So here we have 4 oxygen, so 4 into 16. If you sum up all the atomic mass, we get the answer 98 grams per mole. And this is the molar mass of sulfuric acid. Gram equivalent mass of sulfuric acid is equal to molar mass of sulfuric acid, that is 98, divided by the N factor. N factor here is the basicity of sulfuric acid, that is 2. So 98 divided by 2, which gives the answer 49 grams per equivalent. So this is the gram equivalent mass of sulfuric acid. Equivalent mass of a base. The chemical entity that we have taken here is a base. For base, the equivalent factor N is the acidity of the base. Acidity of the base is nothing but the number of moles of ionizable OH minus ions present in 1 mole of the base. We know that gram equivalent mass equal to molar mass by the equivalent factor N. So the gram equivalent mass of base E equal to molar mass of the base divided by the N factor. What is the N factor here? Acidity of the base. Now, let us understand this concept with an example. Let us take potassium hydroxide as an example and calculate the equivalent mass of potassium hydroxide. If you see the formula of potassium hydroxide, you could see 1 K plus ion and 1 OH minus ion. The ionizable OH minus ion in 1 mole of potassium hydroxide is plus 1. The acidity of KOH is equal to 1, which is the N factor. To find the gram equivalent mass of KOH, we have to find the molar mass of KOH first. For this, we have to sum up the atomic mass of the elements present in KOH. Atomic mass of potassium is 39. Since we have 1 potassium, 1 into 39 plus we have 1 oxygen, so 1 into 16, which is the atomic mass of oxygen, plus the atomic mass of hydrogen is 1, so 1 into 1. When we sum up all these numbers, we get 56 gram per mole. So now to calculate the gram equivalent mass of potassium hydroxide, we have to divide the molar mass of potassium hydroxide by the N factor. Here 56 divided by 1, which gives 56, which is the gram equivalent mass of potassium hydroxide. Let us consider the following redox reaction, the reaction between potassium permanganate and ferrous sulfate in acid medium. To find out the amount of reactants involved in this reaction, we can use 2 methods. One is gram equivalent concept method, then the next one is the molar concept method. First, let us see the gram equivalent concept method. For this method, no need for us to balance this chemical equation. First, we have to find out the gram equivalent mass of potassium permanganate, then the gram equivalent mass of ferrous sulfate. Students, already we know that how to calculate the equivalent mass of KMnO4. To find the gram equivalent mass of KMnO4, we have to divide the molar mass of KMnO4 by its N factor. Here in this reaction, permanganate is reduced. That is, it gains 5 electron in this reaction. So the N factor is equal to 5. So 158 divided by 5 gives the answer 31.6 gram per equivalent, which is the gram equivalent mass of KMnO4. Now let us calculate the equivalent mass of anhydrous ferrous sulfate. For calculating this, first we have to calculate the molar mass of ferrous sulfate. So what we have to do, we have to add the atomic mass of all the elements present in ferrous sulfate. The atomic mass of iron is 55.9. Here we have 1 Fe. So 1 into 55.9 plus we have 1 sulfur. So 1 into 32, which is the atomic mass of sulfur, and 4 into 16, and 16 is the atomic mass of oxygen. If you sum up all these numbers, we get the answer 151.9. If we round up this number, we get 152 grams per mole, which is the molar mass of ferrous sulfate. In this reaction, iron is oxidized and the reaction is given below. Here in this reaction, Fe2 plus ion loses one electron and gives Fe3 plus ion. Since it loses one electron, the equivalent factor N is equal to 1. To calculate the gram equivalent mass of ferrous sulfate, we have to divide the molar mass of ferrous sulfate by its N factor. So 152 divided by 1 gives 152 grams per equivalent, which is the gram equivalent mass of ferrous sulfate. Knowing the equivalent mass of KMnO4 and anhydrous FeSO4, we can say 31.6 gram of KMnO4 reacts with 152 gram of FeSO4 using the gram equivalent concept without writing the balanced chemical equation. We prefer the gram equivalent concept to find out the amount of reactants involved in a redox reaction. For the same reaction to find the amount of reactants using mole concept, we need to balance the chemical reaction. Then only we could find out how many moles of the reactants are involved in this reaction. Here, 2 moles of potassium permanganate reacts with 10 moles of ferrous sulfate. So to find out for 31.6 grams of potassium permanganate, we need to cross multiply and we get the answer 152, which gives the amount of ferrous sulfate involved in this reaction. Students, let's recall all the concepts that we have discussed in this session. We have discussed about the definition of gram equivalent mass, learn how to find out the formula for gram equivalent mass of oxidizing and reducing agents and for acids and base, and we have learned how to compute the gram equivalent mass for oxidizing and reducing agents and for acids and base. Hope this session was useful to you. See you soon in the next session. Have a nice day. Thank you.